Hey everyone, welcome back to the shop. I'm Rob, and today I'm not actually building a prop, I'm building a machine. Now, over the last 6 months, a year, I've increasingly needed the ability to do things like cut paint masks, etch PCBs, all this stuff where I'm just thinking, if only I could throw this in a laser. So that's what I'm going to do. Now, I have a table full of parts, and this much of an idea of how I'm going to do it. I have a rough outline in my head, and we'll probably play with some ideas on the board here, but for the most part, kind of going to be making it up as we go along. Now, there's a reason to be making it up as I go along. Instead of providing a sort of finished product, here it is, here's the blueprint, this is how to do it, this is what it is, kind of product, which I don't think is really very useful most of the time. Typically, when people are going to be doing something, they have a very specific set of goals in mind, and they're really just mining these videos for sort of translatable techniques and concepts. So what I want to do is more look at the development process as it moves along, underlying concepts, whatever sort of problem solving areas come up in the process, and generally approach it more from a sort of machine design perspective. What that actually really changes isn't much, most likely. In terms of the build itself, actually recording before building anything, the only thing that really changes is I have to build from the inside out. I have to build the thing that does the thing, and then sort of build the machine around it in order to provide the parameters that I need it, instead of just building the frame and then shoving everything inside it, which relies on a sort of pre-designed process. And that's really it. So with that said, first I'm going to take a look over the stuff on the table. Most people watching this video probably already have a pretty good idea of what all this stuff is, but just to make sure we're all on the same level here, we can do that. And then I'll start taking a look at the first aspects of the build. Alright. Okay, so for the components, I'm going to start on the mechanical stuff and work my way over to the electronics. The main thing with this build is it's going to be built around OpenBuild's V-slot. It's an aluminum extrusion which has a V bevel extruded into the sides of the standard size and shape channels that allows these V-profile wheels to roll in it nicely without needing a separate V-profile and different shaped wheels and all of that stuff that used to make it a little trickier to do builds like that. Now, more open build stuff, lots of screws, M5, different sizes, different lengths, some M3s, nuts, washers, T-nuts for the extrusion. They slide along so you can screw things into the or onto the extrusion and then sandwich it together. These wheels are made of Delrin. You push a little ball bearing into each side of them, and it just holds there, and you end up with a wheel like this. Different sizes of bearing and types of bearing for different parts of the machine. Some old stuff that I've had lying around for a couple of years. This is from the camera slider. A couple of you might have seen that. The timing belt, I think this is MX2? No, GL2. I want to say GL2 timing belt. That's 2mm pitch. And pulleys, tooth pulleys for the timing belt, different sizes of that. The belt drive will be X and Y axes. The Z axis will obviously be this Acme threaded rod right here with its brass nut. I didn't get the preload type nut because this is always going to be preloaded by gravity, so I don't need extra springs and stuff in there. There's no point. That's that stuff. I've got these 8mm chrome hardened linear guide ways with the linear bearings. Let's see. That go on them, so instead of going round and round like this, they actually move back and forth like that, and the bearings inside run along the axis. I think that's it on the mechanical stuff. I've got aluminum stock, different sizes, different shapes. I've got some more elsewhere. This is just illustrative. Some of the frame will be built or machined from stock. Machined, welded, whatever. I'm not sure how I'm going to do it yet. This is the main thing that I have designated so far. It's 2x2, 2-inch cube. This is going to be the actual laser housing. Not 100% sure what that's going to look like yet, but that's what it's going to be made from. And that's it. So onto the electronic stuff, usual stuff, power supply, multimeters, whatever stuff you would expect. Arduino Uno, I'm going to be running Gerbil or Gerbil, whatever, to as the actual motion controller for this project. So that runs on an Arduino. We've got the motor driver board with drivers installed. A bunch of little international rectifier, Z44 MOSFETs. They are to turn the laser on and off and possibly do pulse width modulation on the power of it, if I can see how to set that up. Stepper motors, couple different sizes. There's a little short one there. They're all NEMA 17 on the mounting style, so mounting them should be fairly straightforward. This one is already actually mounted to a open builds end bracket from the camera slider again. That's those. We've got these are optical I open these. Well, I had one of these open, but these are optical limit switches. There's a little photodiode and an LED, infrared LED, and you mount a dot on the moving parts of the machine which blocks the signal at the limits of the travel. So you have two of those on each axis, so that in theory the machine can't crash itself into itself. Sometimes easier said than done. What else is there? Thermal grease, because I'll be using the housing as a heatsink as well. Fun little sticker, because danger stickers are always fun. And then we're on to the laser itself. This is the copper housing it came in. I just ordered it from DTR Laser Shop. If you follow my Instagram, you'll have seen some experimentation with this last year sometime when I was getting ready to start this project the first time. This is a Nichia 7875, I want to say. It's a 445 nanometer blue laser diode, about 2 watts, I think. Runs about an amp, 1.2 amps, something like that. We'll see that later in the process. It came with, or I ordered it with this G2 style lens already attached, but I didn't order it with the constant current laser driver, which in retrospect I probably would now. For the time being, I can just constant current drive it from the power supply, but eventually I'll, once I'm sort of used to its operating parameters, I'll actually build a constant current supply and mount it to the carriage on the gantry for it there, so I can operate the whole thing from, I guess, an ATX PC power supply. That would probably make sense. That's it, except for the most important part. Spend the money on decent safety goggles or glasses. The $5, $10 ones don't necessarily work. I think these were about 40, and they're actually specifically intended to block sort of blue-green laser light. 190 to 540 nanometers. So blue, a little bit of green, and then down into the ultraviolet, which is cool. Good laser safety glasses. Cost a little bit of money. I think they were about $40, something like that, which is more than anything else cost except the laser itself. But you know, our retinas are kind of important in the grand scheme of things. So yeah, that's that. Oh, I missed this cable carrier. This is kind of optional, but if you want the whole thing to be kind of neat, then this is a fun little addition for the carriage and gantry area. Okay, that is it. On to design considerations. Okay, I have 3 main design considerations for this build. Not quite client requirements, but sort of in that general vein. Number 1 is this thing cannot have a bed. It has to be portable. So number 1, portability. Now, most laser cutters or laser etchers or other small type builds have a traveling sort of bed carriage with a fixed gantry over the top, and then this goes back and forth this way, and then whatever you're doing to it, 3D printing or laser or whatever, this goes back and forth and up and down. I want to get rid of this bit. So more like a traditional tube laser, where you have a tube in the back and then it sends the laser through the system via a series of mirrors and then brings it to the gantry and then through the lens to do the cutting. So what I'm going to do is we're going to have the head on the gantry, and then this is going to move forwards and backwards. Let's change that, there we go. So this can go up and down on the z-axis, and then there are going to be rails here, and these are going to have the wheels on, and then this whole thing is going to go forwards and backwards. So once you frame this whole bottom end in, you can literally pick up the thing and put it anywhere on anything, and you can cut or etch or what's the word, sort of pyrolyze wood burn, paper burn, whatever, anything you want. Number 2, the actual emission point of the laser housing has to remain the lowest point on the entire gantry system, excluding the legs, obviously, at any time. So, due to the portability thing, I don't know what the geometry will be of whatever I'm laying it on. So, I'm erring on the side of caution and making sure there's nothing sort of sticking down below where the focal point of the laser would be. So, traditionally, on a lot of systems, you would have this Z-axis sort of sideways gantry mounted onto the gantry, and then you would have another carriage that moves up and down with the actual tool mounted onto, whether that's a laser or a milling attachment or whatever. But if that is a laser, and you have the laser mounted at this height, and your focal point is here, well then you need your material to be there, and this is then crashing into it. So, the variability of this means this cannot be the case. So instead what I'm going to do is fix the Acme rod and the hardened rails directly to the actual carriage itself. And then it's just a case of figuring out the rest of the system to make sure they can be stationary and locked in place. With the guide rails, it's pretty easy. You just attach the linear bearings to the gantry or to the carriage on the gantry, and then the rod can just slide up and down inside it. It's not a problem. With the Acme thread, either you have to sort of mount the motor sort of floating up here in space attached to the carriage, but then if you do that, the motor has to be hollow because this rod is going to move up inside it. So what you actually have to do is completely assume this is looking down the gantry. You have to move the motor to the opposite side of the gantry, gear it with our timing belt pulleys, and then attach another pulley here to the nut, which the switch to another color, which then allows the Acme rod to slide up and down as it turns, and then you mount this at the bottom of that. Those are the only two actual this is what I want, like, requirements. The whole thing design wise, other than that, is fairly nebulous. I'm not 100% sure how it's going to go. We'll see. But that said, there is one more. Consideration number 3. I'm not 100% sure what the limits of focal length are on that G2 lens, but because of the difference in focal length between etching and cutting, I kind of want to accommodate the entire range and then ideally a little bit more. As you lengthen the focal length out, I suspect it'll also kind of make the beam a little fuzzy, so I'll probably have to make an executive decision about where that cutoff's going to be. But for the most part, what I'm looking at is the actual geometric differences in the beam between etching and cutting. That doesn't make any sense. We'll put it up here. Okay. So if you're etching, you want the beam to have a nice short focal length. Let's pretend that crosses on the material. You want the beam to have a nice short focal length so that it gets fuzzy and weak each side of the material and it's not causing burning like inside the material. Since laser power is based on intensity, which is power per unit area, as it comes in, it gets super powerful, and then as soon as it starts coming back out again, it gets weak and can't do anything. Which for etching is ideal. But for cutting, you want to use a longer focal length because, as you can see, the amount of time it spends above some arbitrary intensity required to cut the material is much deeper, and therefore you can cut a greater depth of material in a single pass. So because I have the option of the focal length on this, I don't think I'm going to be cutting more than an 1/8 inch material, so the actual variability doesn't need to be super high in terms of number of Z passes, but I do want to accommodate as much of this as possible. So I'll do some experimentation on exactly how much range I can get out of it, and then the Z-axis will be a little bit more than that, just to adjust for focus and whatever. I'm suspecting that's going to be somewhere in the range of 4 inches. That's what I'm intending on. If it's a lot more than that, well, that's kind of a design limitation. I can't really go too far out before, you know, the top of the Z-axis is sort of waving around and causing instability. So I'm just going to go as far as this lets me take it, basically. That's it. Okay, I think I've yapped on quite enough for one video. It's getting a bit longer than I would like. I'd originally anticipated this whole intro section to be like 10 minutes, but never mind. So what I'm going to do is shut it off here. So I'll put a pin in that for the introduction section, and then we'll launch straight into part 2, which will be putting together the laser housing and the Z-axis as one assembly. I think I have 4 build parts planned. Second part will be putting together the rest of the gantry and that may be it. The gantry and those 2 axes, I think. Part 3 will be framing up, wiring up, and part 4 will be configuring Gerbil and test cuts, I think. I'll double check, but I'm pretty sure it's something like that. So, if this project seems like something you're interested in, I'll try and get part 1 out like super close, almost back to back, maybe a day or 2 in between. So if you like the sound of this, then I guess subscribe so you get that. And yeah, see you then. Thanks for watching.